All right, in this video, we're looking at example 3.8, try and write large for the sake of quality. Okay, if we look at the slide 26, says a packet of artificial sweetener contains 40.0 milligrams of saccharin, right? And I'm more concerned with the formula at this point, C7H5NO3S. We're given the structural formula below, and we're asked how many carbon atoms. Okay, so what do? Okay, well, I start with the only number I'm given right here, 40 milligrams, and I've got to make my way all the way to atoms. Okay. So I got 40.0 milligrams. I know I can't go right from grams to atoms. I have to go to moles first. Okay, but the fact that I'm given milligrams is significant. Right? I can't go straight from milligrams to moles. I first have to convert milligrams to grams. And this is just an old chapter 1 type conversion, right? There are 1,000 milligrams in 1 gram. Okay. And now I could, if I wanted, or I will, go from grams of saccharin to moles. But I don't have an atomic mass. It's not straight from the periodic table. This is a big problem because it's also requiring me to calculate the formula mass for saccharin, which I need in this problem. Okay, so I take my carbon, right? 7, my hydrogen, 5, my nitrogen, 1, my oxygen, 3, my sulfur, 1. And I have to multiply them by their respective atomic masses to get the overall formula mass. Yep, and I pull these from the periodic table. 12.01 for carbon, hydrogen 1.008, nitrogen 14.01, oxygen 16.00, and sulfur 32.06. I multiply all of these together and add them up. Okay, so you can take time and do that on your own. You should get a final answer of 183.18 grams per mole, which is what I need for this conversion up here. 183.18 grams of saccharin in 1 mole. Yep. So now if I stop the conversion, milligrams will cancel, grams will cancel, and I'll be left with moles. But I am not done yet because I'm asked about atoms. Okay. And how do I convert from moles to atoms? Well, you should know by now, or hopefully you're at least getting used to the fact that 1 mole, in this case for saccharin, is equal to 6.022 times 10 to the 23rd molecules. Okay. So moles cancel out. I'm left with molecules there. I do my math. Right, on the top, I have 40 times 6.022 times 10 to the 23rd. On the bottom, I have 1,000 times 183.18. And then I take those numbers and divide them, right? Numerator over denominator. So should look like that. Again, quality not great, but hopefully you can do that in your calculator, all right? And I get a final answer, right, just moving down here with 3 significant figures, 1.31 times 10 to the 20th molecules of saccharin, C7H5NO3S. Okay. But be careful, and this is where word problems in chemistry can be tricky. This question asks how many carbon atoms are in saccharin, and I solve for how many molecules of saccharin that I have. So I need one more conversion to get my final answer here. Okay, I have 1.31 times 10 to the 20th molecules, and now I just have to come up with one new conversion factor. For every 1 molecule, how many carbon atoms do I have? Well, we already did that, right? Right here. 7 carbon atoms. So I multiply that answer by 7 to get my final answer, which is 9.20 times 10 to the 20th carbon atoms in 40 milligrams of saccharin.